In this video, I want to introduce you to the idea of a variable. So let's look at this example. Let's say a 7th grade math teacher has to make a record of how many students are in her class every day. And we will represent this number as number of students. And on Monday, the teacher counts that there are 26 students in her classroom. So on Monday, number of students is equal to 26. And on Tuesday, let's say there are less students in class this time. So Tuesday, the number of students is equal to 19. We'll say they're equal to 19 this time. And notice how this value will change day to day. And this is what we call a variable, right? And in math, we represent variables or varying values. It's really all variables are with a letter. And in this example, we could represent the variable number of students just as S. We could have just said S for this. And we can represent this with any letter. A common variable you will see in math is X, right? X here. This is the most common variable that people use to represent a varying value, but you don't need to worry as much about the letter as you do what it's representing. And in this case, the variable S, or number of students, or X, whatever we wanted it to be, is just representing the number of students that the teacher counted in her class on a specific day. So let's look at another example here. Let's say that we work at a restaurant and we make $12 an hour plus the tips that we earn during that hour as well. So this time let's try to write an expression to solve for our hourly pay. So we already know that we're going to earn $12 an hour no matter what, right? And then we add on the tips for that hour, right? Tips for that hour. And this is going to give us our hourly pay. But since we're trying to solve, problems regarding variables, let's instead write t instead of tips, right? So I'll write up here, I'll write up here, tips are equal to t. And notice how I write t a little bit like slanted here, a little bit curved. That's so we don't get t confused with this plus on here, right? So 12 plus t is equal to hourly pay. Now that we have our expression here, let's try and solve for our hourly pay for specific hours. So let's say at lunchtime, 12 p.m., there's a lot of people in the restaurant, so we make $40 for that hour. So at 12 p.m., we earn $12. Sorry, let me write this sound a little bit better. We earn $12 plus our $40 tip. So at 12 p.m., our pay is $52 for that hour. And then let's say around closing time, there's only one person that comes in, right? And they give us a $5 tip. So our pay for, let's say, 8 p.m., right? Let's say at 8 p.m., we have our $12 for that hour, and then we only earn $5 for tips. And this will be $17. And I guess I could write, the USD sign. And notice how t changes, right? This is a variable. The value of t is changing. That is the definition of a variable. And we could have said that t was x or any other symbol, but it doesn't matter because we're just worried about what t represents, and that is the hourly pay. And now let's talk about some terminology when it comes to variable expressions. So let's say we have this expression here, 3x plus 5. And this time we're not necessarily worried about what the x represents or what this whole equation represents. I just wanted to tell you how we classify and talk about variable expressions. So you'll notice here in this problem, this x is a variable, right? We don't know the value of x. So this is going to be the variable. And you'll notice here there's just a 3 sitting right beside this x. And when there is a number right beside the x, this could be a whole number or integer, fraction, decimal, anything. This is an implied multiplication. So 3 here is being multiplied to x. And when something is being multiplied to a variable in algebra, we call this a coefficient, right? We call 3 the coefficient here. So let me write that. 3 is the coefficient. And there is just a 5 here, and this is just a whole number. But what I want to point out is that there are two separate things here. There's two quantities being added, and both of these we will call, I'm just going to do this out here. Both of these are terms. And we call things that are separated by addition or subtraction terms and problems. So we could have 25, and I'll write this here, 25x plus 3x to the second power, right? And these things here that are separated by an addition sign here, these are both going to be terms. So this is a term, this is a term, and this is a term. And we could have, I'm going to scroll down a little bit. We could have 18 plus 3x. These are terms, right? They're separated by an addition sign. So there are two terms. 18 is a term, and then 3x is a term. Hopefully this helped, and we are done.